Okay, given that I squeeze the handles with 30 pounds of force, what I want to find is how much clamping is going on over on the other side where I'm clamping some something together over on the other side. Okay, so this is a machine that I'm dealing with, and I want to figure this out. Now, as I go through and look at things, one key thing to recognize is this member right here, member CA, and recognizing that CA is a two force member. And because it is a two force member, okay, I know its direction. Okay, so then rather than having like a CX and a CY or AX and AY, I know I just have one force in that direction that I'm trying to deal with there. Okay. Now, with that, I also recognize that that bottom handle is only going to have three unknowns on it. So if I draw the free body diagram of the bottom handle, I've got the 30 right here. I've got dx, I have dy, like so, and then of course I've got c up at that direction right there. And that direction, again, knowing that this is 0.55 in this direction, and this is 1.3 in this direction, I can find that angle to be 22.9 degrees. Again, just doing an inverse cosine on this one. Okay, and I'm going to recognize that what I mostly want to find here is member C. I can solve any of these values right here, but most importantly, I'm going to look for C. So in order to find C, I can take the moment about D, because I don't care what it is, dx and dy will go away. And what I'll have is 3.4 times 30, okay? And then I'll have the components of C that I have to worry about here as well, which will be 0.8 times C sine of 22.9, okay, and negative 0.3 C cosine of 22.9, basically the horizontal and vertical components. So again, I'll take a vertical distance times a horizontal force, and then a um, horizontal distance times a vertical force. Okay, but the bottom line here is I've got one equation, one unknown, and I can find that C equals negative 2880. And that negative sign tells me that I drew that C in the wrong direction. Rather than that two force member being in tension, it's actually going to be in compression. Okay. Now from that, now I know, based on Newton's third law, I know what's going on at A. So I can draw that top member there, which is what I'll do right now. Not very well, but you get the idea. Okay. Where I'm going to have 30 over here. I've got this A force, which again is going to be in compression. Okay. Again, I drew it incorrectly last time, so I'm drawing it correctly this time, and I've got the 2880 here. I've got B, which is not connected to the two force members, so I've got BY and BX here. And then I've got the clamping force. Now, remember, it's the force on the member, not the force that the member places on the object, right? So that force is that clamping force that's pushing against my object, right? Force is on my object. A lot of people draw that in the wrong direction, and I'm going to call that F. Now, I am looking for F. I don't care about B. So if I sum the moments about B, okay, the only unknown will be F, because now I know the force at A, that compressive force of 2880, right? So from that, I'm going to take negative 3.2 times 30, okay, negative 2.6 times F, okay. Obviously, Bx and By are both 0 about B. Then the only thing I've got is the horizontal distance of 1.9 times the vertical force of 2880 sine of 22.9 degrees. And again, that's the same angle here, 22.9 degrees given there. Set that equal to 0. Okay, this is just one equation. Okay, and I get that equation equal to F, which is 783, and that's going to be pounds. So squeezing with 30 pounds, okay, creates nearly 800 pounds of force at F. We call that the mechanical advantage. That mechanical advantage is, oh, I'm 315 or something like that. You can figure that out just by dividing 783 by 30. No, 26. Anyway, you do the value on your own, but it's basically how much more force do I get out than I put in. So if I put in 30, I get out 38.3, which is the whole point of machines a lot of times, is to get a small force and turn it into a very, very large force. And again, we do this just by breaking up the member into individual pieces, recognizing two force members, and using that to help move through more efficiently.